In this video, we're finding sine of 2x given sine of x is equal to 1/2 and x is between pi over 2 and pi. The first thing that you want to do whenever you're dealing with any type of double angle or half angle identity and you're solving a trig function of it is you want to check what quadrant or quadrants your double angle or half angle is within, because that'll decide whether you have a positive or a negative answer. So if we were to make a little chart over to the side, between pi over 2 and pi means that we're between this quadrantal angle and this quadrantal angle, meaning that we are currently in quadrant 2. But if we want to solve for 2x, we have to multiply each of these values in our inequality by 2 to get that 2x. So in the first case, 2 times pi over 2 will just give us pi, which is less than or equal to 2x, which is less than or equal to 2 pi. So from here, if we were to look what values this represents, we just said pi is this quadrantal angle, and we know that 2 pi means we've made one complete rotation, which is this quadrantal angle. So 2x is somewhere between these two quadrants, which are quadrant 3 and quadrant 4. Now, what do we know about sine in quadrant 3 and quadrant 4? We know that sine of any angle theta is less than 0 when we're in quadrants 3 and 4. Remember, that comes from our ASTC, or All Students Take Calculus. So sine of theta is less than 0 in quadrants 3 and 4, which means in this case our angle theta is 2x. So whatever angle we're dealing with for 2x, we know that its result will have to be negative. Okay, so with that in mind, let's start solving this out. We have sine of 2x. We know that we can rewrite as 2 sine x cosine x. This is our most common double angle identity, and it's one worth committing to memory, especially if you're going on into Calc 1 and so on. So we already know sine of x. We could plug that in right now. We have 2 times sine of x is 1/2 times cosine of x. But in this case, we don't know cosine of x yet, and we can find it using our Pythagorean identities. Remember our Pythagorean identity? Our most common one is sine squared x plus cosine squared x is equal to 1. So if we replace sine x with its value of 1/2, we'll get 1/2 squared plus cosine squared x is equal to 1. And at this point, we can just start solving for cosine x. So we'll first evaluate this 1/2 squared, which gives us 1/4 plus cosine squared x equals 1. We'll then subtract 1/4 from each side of the equation, leaving us with cosine squared x equals 3/4. Just a quick reminder, 1 minus 1/4, we could rewrite 1 as 4 over 4 minus 1/4, which gives us that 3/4. And now finally from here, we can take the square root of each side of the equation, giving us cosine of x is equal to plus or minus the square root of 3 over the square root of 4. Remember, whenever you have a fraction inside of a square root, you can take that square root and put it over the top and bottom separately. And we do that because now the square root of 4 just leaves us with 2 in our denominator. Now we have two answers here, and we need to get one of them to solve this problem. So if we check what quadrant we're in, we know that cosine of x is in quadrant 2. So x is in quadrant 2, that is. And cosine of x is negative in that quadrant. So we get cosine of x equals negative root 3 over 2. And now we can plug that in for cosine x in this problem. We have 2 times 1/2 times cosine of x, we said, is negative root 3 over 2. And now we just want to start simplifying. 2 times 1/2 cancels out, leaving us with just 1 times the negative square root of 3 over 2. We get sine of 2x is equal to the negative square root of 3 over 2. And now we'll just do a quick check to make sure that our sign is in fact correct. Earlier we said sine of 2x has to be less than 0 because 2x is in quadrant 3 and quadrant 4. And sure enough, sine of 2x is negative in this case.